We start this lesson off with a definition. It says, given two functions f and g, the composite function denoted by f, and then you have like this little circle here, g, and that reads f composed with g is defined by, and then this is wrote out here. And so I kind of already started this and did an example here. When you have f composed of g, and over here it says x, then that is f of g of x. So basically what we are doing is we are inserting a function into another function, or sometimes we'll even composite it inside its own function. Okay, but it's a function within a function. So here, following that same logic or pattern, if I have f of g of 1, that can be expanded out to f of g of 1. Okay, so with composites, we always start with the inside function. So I have put my g of 1 in red. So now let's work out what g of 1 is. My g of x function is 3x squared. So now I'm going to take this function, I'm going to replace this x with what x equals with this 1. So we have 3 times 1 squared. You can put this all in your calculator, but exponent rules say order of operation rules say exponents first and then multiplication. So this is 3. And so now I have evaluated what g of 1 equals. So now we're going to go back to f of, and what did g of 1 equal? It equaled 3. Now we're going to evaluate f of 3. So now I'll go over here, my f of x function, 5x minus 1, and replace this x here with what x equals, which is 3. So we have 5 times 3 minus 1. So 15 minus 1 gives me 14. Now in part B, we're going to use the same two functions, but now we're going to go opposite. So if I have g composed of f of 1, that is g of f of 1. So let's see if order matters with composites. We'll start inside. So first we need to come over here to our f of x and evaluate when x equals 1. So I have 5 times 1 minus 1. So we get 5 minus 1 to give me 4. Okay, so now we got g of, what did f of 1 equal? It equaled 4. So now we'll come over here to our g of x function and evaluate when x is 4. So we have 3 times 4 squared. 4 squared is 16 times 3 gives me 48. You can see here, order matters. Make sure you follow the order that is given to you. Now, as I said up above, composites is usually putting a function in another function, but we can put the function inside the same function. So part C, if I have f of negative 2, if I expand that out, that is f of negative 2. Starting inside, evaluate what f of negative 2 is. So I'm going to plug that into my f of x function. So I have 5 times negative 2 minus 1. So negative 10 minus 1 is negative 11. So that is what f of negative 2 equals. So now we have f of negative 11. And go back inside that same function. So we'll have 5 times negative 11 minus 1. Negative 55 minus 1 is negative 56. So the same thing, but use our g of x function twice. So g composed of g of negative 2 is g of negative 2. Starting inside, we will substitute a negative 2 in place of our x here. So I have 3 times negative 2 squared, which we get 4 times 3 to give me 12. So then g of f of 2, we just evaluated to equal 12. And now go back into that same function and replace that x again, now with 12. So 3 times 12 squared, 12 squared is 144, times 3 is 432. Okay, now, in example 1, we were given both of our functions and we had to insert our values of x to get our y values. We're going to continue on to the next page doing the exact same thing, but the information is just going to be given to me differently. So again, this time I was actually told what the functions equal. I was told my f of x function equals, my g of x function equals. This time I am given a table. If you can read this table, this is actually easier because there's no substituting in and evaluating. They're telling you every bit of information here. So to help you understand this table, we have our x values here, our f of x values here, and our g of x values here. So if they wanted f of -3, we would go to our x. Our x is -3. And because I want f of -3, I'm going to go to my f of x. So I would go right here down below. And so that equals -5. Or if they wanted g of -3, my x still equals -3. But now because it's my g of x, I'm not going to go down to this middle row. I'm going to go down to the bottom row. And this one equals 8. Okay, so rewind that if you need to see that again, but that's what we're going to be doing for all of these here. Okay, so on part A, we have f composed of g of -2, so that is f of g of -2. So starting inside, first we need to evaluate what is g of -2. If I go along my x column to -2, because it's g of x, I'm going to go down to that bottom, and that's 2. So now you evaluate f of 2. So go along your x to 2. Because I want f of x, I'm going to go down to this middle row, which is 3. So that's my answer. Okay, maybe watch B and then try pausing and try C and D on your own. On B, we have g composed of f of 1. So this is g of f of 1. So let's figure out what f of 1 equals. So go along your x to 1, and we're going to go down below since it's f of x, and it also equals 1. So now g of x is 1. Go down to that last column, and we get 0. Okay, so pause the video and see if you can do C and D on your own. Okay, I hope you paused. So let's go through this. We have f composed of f of 2, which is f of 2. Starting inside, f of 2 is 3, and f of 3 is 5. And then we have g of 0. So what is g of 0? As I go along my x to 0, we get -1. And then g of -1, go along that x to -1, and g gets me back to 0. So that's how we use that table to evaluate. If you can understand that table, this is much easier than what we did in example 1. And then example 3, we're doing the same thing again, but now I'm reading my y values or my f of x and g of x values off of my graph. So to understand this graph, they have them labeled. We have our g of x is this one right here. So this looks like a polynomial. And then my f of x is this V shape. So if this is a V shape, my f of x function is an absolute value. Okay, so f of x, or sorry, A says f composed of g of 1. So if I write that out, That is f of g of 1. So let's start with the inside. And let's evaluate what is g of 1. And that will go and right here. So I'm going to go along my x to 1. If I wanted f of 1, I'm already on it. But I want g of 1. So I need to go up to meet this graph. Here's my point on my g of x function. What is that y value? When x is 1, that is 6. So now I need f of 6. So go along your x to where x is 6. Because now I want my f of x. I'm not going to go up to meet this graph. I'm going to go down to meet this graph. Here is my point. What is my y value when my x is 6? That is -5. Okay, let's go through these a little bit quicker now. Here we have g composed of f of 1. So g composed of f of 1. So let's first evaluate f of 1. Go along your x to when x is 1, and we're already on our f of x function. So what is that y value? That y value is 0. And then now go along your x to 0. We're going to go up past this one because that's my f of x. Go up past that one to your g of x function. And what is that y value? That is 7. So again, to reiterate, these are not the same things. Order matters. One's a -5, one's a 7. Now compose your function within itself. We have f composed of f of 2, which is f of 2. So first evaluating f of 2. Here's where my x is 2. Go down to meet your graph. What's that y value with this ordered pair? That's your -1. And now go to -1 on your x. We're going to go up to meet this graph. And what is that y value? That y value is at 2. And then last one, g of 0. So what is g of 0? Well, we've already done g of 0 before. That's 7. But to show, we go along that x to 0, go up to meet that graph, and that y value is at 7. So now I need g of 7. So here's my 7. Go up to meet that graph, and what's that y value? It's again 7. Now, I don't ask this question, or maybe I need to actually add it in the notes, but I believe something in your homework's going to ask, what's the domain of this graph? And so remember, domain has to do with all of our x's. Okay, so my domain, you want to see values that they share, right? So they both start at -1, and that's included, so we'll do bracket. And then it keeps going. My g of x stops at 7. My f of x stops at 8. So we need the numbers that they have in common. Because my f of x has no numbers right here between 7 and 8, I can't include the 7 and 8, so it stops right here at 7. Because here is where they both have x values. I guess we can keep going down that are included on this graph. So we're not going to include this little bit right here because our g of x function does not have that. So I do believe that's a My Math Lab question. So that should help you on that.